This is number 105 in section 2.5. A bulk food storage bin with dimensions 2 feet by 3 feet by 4 feet needs to be increased in size to hold 5 times as much food as the current bin. We're going to assume each dimension is increased by the same amount, so we're going to write a function that represents the volume V of the new bin. So we know the current box is 2 feet by 3 feet by 4 feet. So we make a little drawing. We can say it's 2 feet by 3 feet by 4 feet. And so we can find out the current volume of that box just by multiplying length times width times height. So that will be 2 times 3 times 4. So that volume is 24 feet cubed. And so we want to increase the size to hold 5 times as much food as the current bin. So what we're going to do is we're going to multiply 5 to 24 to get the new volume that we want. So that number is, 5 to 4 is 20. So the number is 120 is what we want the new volume to be. Now it says we're going to increase each dimension by the same amount. And so increase, so we're going to add a number to each length. Okay, so we can say our volume, we can say volume of x is going to be x plus 4 times x plus 3 times x plus 2, and that's going to equal 120. So we can go ahead and multiply this through. So this will be, the first two terms will be x squared plus 7x plus 12. And then we're going to multiply the x plus 2. And so this is 24, 14x, 2x squared. And then we have 12x plus 7x squared and x to the third power. So this is x cubed plus 9x squared plus 26x plus 24. And so let's write our function. So volume is x cubed plus 9x squared plus 26x plus 24, and that needs to equal 120. So that is part A. So now we need to find the dimensions of the new bin. And so what we want to do is set the equation equal to 0. So we're going to subtract 120 from both sides. And so we will have x cubed plus 9x squared plus 26x minus 96. Now, even thinking about Descartes' rule of signs, we can see how many positive numbers we have. And we can't have negative, right? We have to have a positive volume, positive measurement. And so we only have one sign change here, so everything's positive except for here, that negative 96. So we know that we only have one positive real root possible. So there are a lot of numbers for 96. So if we were to list that out, it'll be 1, 2, 3, 4, 6, 8, 12, 16, 24, 32, 48, and 96. So I believe those are all the factors of 96. And so we're just going to test, right, using synthetic division. 1 still seems a little small, and we want to increase it by 5. So maybe I will try 3, and let's see what happens. 3, 12, 36, 72, and then we multiply by that 3, and so that's definitely not going to work, right? That's too large. So maybe I'll try a smaller number. So let me just go a little lower. Let me just try 2. Right, these are just numbers that I just picked. There isn't anything in specific why I chose it. I just, thought about it. I'm going to make I want the box to be able to hold a volume 5 times more than the original. So I'm hoping it's a smaller number. So let's try 2. And 2 times 48 is 96. So there is our answer. So we know that the length that we were going to add to each side of the box is going to be 2. And we don't really need the depressed polynomial on there. That's not going to be factorable, right? We know there's one positive real root, and then so the other 2 are definitely going to be imaginary. And if you look at your result, that's not factorable. So we know that x is 2. So we're going to go back. It says to find the dimensions of the new bin. So all we're going to do is we're going to add 2 to each of the dimensions from up here. So 2 plus 4, and then 2 plus 3, and 2 plus 2. So those give us our new dimensions. So that's going to be 6 feet by 5 feet by 4 feet. It is the new dimension of the bin, and so that is B. I hope this helps.